Okay, next in our study of trig, we're going to talk about drawing reference angles, even if we don't know the size of the angle. If we have a point, but we know it's on the terminal side of an angle, and we know that angle is in standard position, we can still draw the picture. Okay, so we have to estimate where that point would be. 4, negative 13. That would be 4 to the right, and then 13 down, so it'd be somewhere down here. You don't have to draw this very accurately. If the angle is in standard position, we know it starts at 0 degrees. And if this point is on the terminal side, we know we'd finish drawing the angle by drawing a ray through that. So the angle is this bigger than 270 degree angle, theta. And the reference angle would be between where we finished and the x-axis, so right here. Alrighty, so how can we do anything else with this? That seems like enough, but there's more. If we connect our point to our x-axis, just straight up to our x-axis, notice we make ourselves a right angle right there, and lo and behold, we have a right triangle. So now we can, I'm going to put that prime back on there for theta prime. Now we can do all the things that we've ever done with right triangle trigonometry, sine, cosine, and tangent, Pythagorean theorem, all of those things to figure out measurements on this triangle and this angle. So what can we use to find the size of that theta prime, that green reference angle? Well, we can use the sides of the triangle. If we're looking from that angle's perspective, we know over here is the opposite, and we know this is the hypotenuse. So up here on the top would be the adjacent. And, believe it or not, we actually know how big two of those measurements are because we knew what point we used to draw this. When we went 4 to the side, we made the adjacent 4. And when we went 13 down, we made the opposite, negative 13. Now I want you to keep the negative on there because that keeps the triangle underneath the x-axis. If we remove the negative like we might have in a geometry class, then we would allow that triangle to float up above the x-axis. Here in trigonometry, we want to keep that negative because it keeps the triangle and the angle in the correct location. If we let it move, suddenly it's not going to be between 270 and 360 anymore. Alrighty, so if we know the opposite and the adjacent, how can we find the angle? SOHCAHTOA. Opposite and adjacent. That's tangent, isn't it? So we would do tangent of theta prime equals negative 13 over 4, opposite over adjacent. And then you have to ask yourself, hey, is this the type where I do cross multiply divide, or is this the type where I do inverse? Well, this is the type when we do inverse. So we're going to do the inverse tangent of negative 13 over 4, and that's going to tell us the size of the reference angle. The calculator tells me that's negative 72.897. Officially, the reference angle is positive always, so when I'm mentioning what my answer will be, I will say that that is a 72.897 degree reference angle. But the negative is going to be very helpful in another step, so I'm going to leave it there for now. All right, let's try one more for good measure before we add anything extra. So first, I encourage you to draw a picture. It's an angle in standard position, so we know it starts at the 0 degrees. And then we have to locate negative 5, negative 11. So that'd be 5 left, 11 down. Okay, so our reference angle is between where we stopped and our x-axis that we're closest to. And we can draw that straight line up and make our right angle over here. So we can label the sides. We know that we went 5 left, so this is negative 5. And then we went 11 down, so we know this is negative 11. So we know our opposite And we do not know our hypotenuse, and we know our adjacent. So if we know our opposite and adjacent, we can find our angle. Again, that's tangent. So tangent of the reference angle equals -11 over -5. And so if we're finding the angle, we're going to do an inverse. Okay, so the reference angle is 65.556 degrees. All right, so now taking it and adding one more step, here's one more point. We'll sketch out where -10, 17 is. The angle is in standard position. -10 and then up 17. Oh, whoops, I'm over here in my math problem. Let's say we're way up here. Remember, not drawn to scale. The reference angles between where we stop and our x-axis, and our triangle is made by connecting your point straight down, in this case, to your x-axis. So remember, we went -10, we went left 10, and then we went up 17 to get to our point. So again, are you noticing a pattern here? That's your opposite, and this is your adjacent. Now, this one is asking us to do something different. Notice it says label all the sides of the triangle and write the 6 trigonometric ratios. So we don't know the hypotenuse, but we need to find it. So we're going to go back to our old learning with a squared plus b squared equals c squared. When you're placing the -10 in this time, you can totally drop the negative, because negative times negative is going to turn positive anyway. So 17 squared plus 10 squared. So that's going to be 389 equals c squared. And then we're going to take a square root. So this 389, when I put that in my calculator, square root of 389 is a decimal. So you're welcome to just leave it as the square root of 389. Okay, then we'll fill out our 6 trig ratios. So sine of theta will be opposite over hypotenuse, 17 over the square root of 389. Cosine of theta is adjacent over hypotenuse, so -10 over the square root of 389. And tangent, let's see if I can write small enough to fit it, of theta prime is opposite over adjacent, so 17 over -10. Okay, and then the 3 reciprocals. Cosecant of theta is square root of 389 over 17. Secant of theta is the square root of 389 over -10. And cotangent of theta is -10 over 17. I do mean theta, not theta prime, by the way, because we've left the negative on the 10. We are really finding the measurements for the original angle that is red, that is bigger than 90 and smaller than 180. So we are really finding the measurements of the original theta, but we were using the theta prime to get the work done. So that's the importance of leaving that negative on. If you have any questions, please ask in class.